A firm manufactures 4 types of wire: W320, W325, W340, and W370 for a wholesaler customer who guarantees a minimum order of 100 meters of each type of wire every day. To be produced, all the wire must go through 4 activities or stages: cutting off, covering with tin, recovering with plastic, and inspection. The next table shows the time in minutes that each wire needs in every stage, the total daily availability of each activity, and the unitary profit measured in euros per meter. Answer the next questions. In the first simplex table, which variable comes into the canonical basis, which one goes out, and why? B. Describe which would be the best daily production. C. Which type of wire contributes more to the total profit? D. Indicate how much time would be left over in each stage. E. If the unitary profit of W340 wire increases, should the firm change the production? And F. Choose one shadow price and explain. If we consider the next decision variables, x1 equals meters of W320 wire to produce each day, x2, x3, and x4 for wires W325, 340, and 370 respectively. The formulation of the problem would be as follows. We want to maximize the daily profit, the data of which are here, subject to the daily time availability for cutting off, which is here, then the daily availability of tin covering here, then plastic recovering here, and finally inspection, which is here. Don't forget to add the restriction related to the minimum demand of 100 meters each day. Here I introduce the data. Note that restriction of type xi greater or equal than 100, I wrote them here. The current canonical basis is P5, P6, P7, and P8, or in other words, the slack variables associated to it. To know which variable goes into the basis, we look at the reduced cost. And as we are maximizing, we have to look for the greatest one, which is this one. So P2, or its variable, which is x2 or W325, goes into the basis. Now, to know which variable goes out the basis, we look at the ratios, which are here, and we look for the list of them, which is this one. So slack tin covering is the variable which goes out the basis, which is P6 or slack tin covering goes out the basic. Question B asks to describe which would be the best daily production. So we solve the problem with WinQSB and we find that we must produce 100 meters of W320 wire, 100 meters of W325 wire, 138.4181 meters of W340 wire, and finally 100 meters of W370 wire. The maximum profit each day could be 4,011 €158. There are no more solutions, as we haven't here an announcement telling that there are alternate. Question C asks which type of wire contributes more to the total profit. So we look at the total contributions, which are here, and we find that wire 340 is the one which contributes more to the total profit, with 1,211.158 euros. Question D indicate how much time would be left over in each stage. We have to look at the slack variables, which are here, and we find that we have 394.3503 minutes in cutting, no minutes left over in tin covering, and so on. Question E. If the unitary profit of W340 wire increases, should the firm change the production? We have to look at the allowable interval of W340 wire, which is 8.1559 up to plus infinite. So, as the current unitary profit for this wire is 8.75, if this unitary profit increases, the result would be in the interval in any case. So the final answer would be no, the optimal production shouldn't change if the unitary profit of W340 wire increases. I choose, for example, the first shadow price, which is 0 for the cutting constraint. As the shadow price is 0, we can say that if the available time for cutting is increased by 1 minute each day, that is from 1,800 minutes to 4,801 minutes, the maximum total profit won't change. If I consider now the shadow price of the tin covering constraint, we have that if daily time for tin covering is increased by 1 minute each day, that is from 1,600 minutes to 9,601 minutes, then the maximum total profit will be increased by 0.4944 euros it's they.